Okay, so I want to talk about this definite integral of this function right here, 3 minus the absolute value of x minus 3. And what I did was I put it on my CAS calculator. I graphed the function, and then what I did was I went over here to analyze. Went to analyze, and I chose the integral, and then it lets you set up these boundaries. I'm going to show you how to do it in just a second, but can you take a second just to write down that we're trying to find, well, let's look at this. What we're trying to find here is this. We're trying to find, wrong color, buddy. We're trying to find the definite integral from 1 to 4 of this thing right here. Sorry, that's a 3, isn't it? 3 dx, right? So I set it up. I didn't, as you can see, I didn't set it up this way in my calculator. I just put it in as a function in my calculator. But I want to break this into pieces. So what I'm going to try to prove here is that this is the same as taking the integral 1 to 4 of 3 dx, right? I'm going to take this constant multiplier of negative out of this, right? The integral from 1 to 4 of the absolute value of x minus 3 dx. So I'm going to prove that on paper in just a minute here, but I just want to look at this for a second. So if you could write this down, this is what we're chasing right here, okay? So I'm assuming you paused the video or whatever it is you did to make this work. So what I'm going to do now is just go back to this, and I'm just going to go back. I'm going to insert this graph, and the first graph I'm going to insert is that of y equals 3. Because if you remember how we had this partitioned out, that's what we had. So I'm just going to have equals 3. And then there it is. Got me? And if you don't mind, I think I'm going to go here and I'm going to analyze. Whoops. Analyze the integral. And then look, just by moving, you can do it this way by using your cursor here, but I'm just going to do it here. And I'm going to set it up. I'm going to try to get to 1 exactly. I'm doing my best. And that's my lower bound. And you can see it says my lower bound. Here's my upper bound here. This is 2, 3, 4. Shoot. This is kind of a pain in the neck with the calculator. One of the things that is more challenging with this calculator is, see how I stopped at 9 perfectly just for a second, and it didn't. Yay me. Okay, so there's that. Now what I'm going to do is, I said, it's this, right? Minus the area of absolute value of, so absolute value, ABS absolute value of x minus 3, right? So here's this graph right here, right? So now what I'm going to do is I'm going to do the same thing. I'm going to go here. I'm going to go to analyze again. I'm going to take the integral here. No, I'm not going to take the integral. I'm going to analyze here. Yes, I am going to take this integral here. And then I have to choose the graph that I want. So now I'm using this green graph here. I'm going to take the same one from here over to here. Now look at this for a second. So what this is suggesting to us is that the area under the absolute value is 2.5, and the area of this whole box, is 9, and 9 minus 2.5, right? 9 minus 2.5 gives us 6.5, right? Okay, so that's what I'm trying to prove here. Now look, I'm going to insert this. I'm going to insert a new graph, right? And now I'm going to put the whole thing in there. I'm going to take 3 minus absolute value of x minus 3. So there's that function. Now this is what I'm trying to prove here. We took the two graphs, right? We graphed just this part here, didn't we? And then we graphed absolute value of x minus 3, and we subtracted their areas, and we got 6.5, right? So look what happens, though, just to prove that this actually works. Look what happens if I do this. From 1 What? I know it's not perfect because the limit here is my ability to control where this little dot goes, but the area is 6.5. So let's go back and look at this now. And this is what we just proved. This is what we proved here. Said here, those three graphs together prove this, that the area of this whole thing is the same as the area of this plus the area of this, right? I took this constant multiplier out here. Now I have the absolute value function. We know that absolute value is, on one side, it's going to be x minus 3, and the other side it's going to be the opposite of that, negative x plus 3, right? Because absolute value functions look like this, right? So one has this, actually we're looking at absolute value function. It's set up correctly now, right? It looks like this, doesn't it? So we're saying from 1 to 3 it has this negative, it's a negative line, and this is the perfect opposite of that. So those are those two lines. We assess them from 3 to 4 here, right? Because from 3 to 4 the slope is increasing. From 3 to 4 here. From 1 to 3 the slope was a negative slope, right? And then all we did from there is we set it up this way, and then we integrated this whole thing out. So I integrated 3dx, which is 3x from 1 to 4, minus the area of this thing down here, right? I'm sorry, of this thing, right? The area of this was 2, and the area of this was 0.5, so 2.5 when I added them together, and I'll show you where that comes from down here, right? When all this simplifies out, I get 9 halves minus 5 halves, which is 4 halves, which is 2, plus this 1 half is 2.5, and 9 minus 2.5 is 6.5. So, you know, I think it would be great if you want, just let me leave this here for a second. Maybe you can pause the video and see if you can track down through this math, and then how I got to the end of this math. But I just wanted to show you using the calculator how that integration is done. And what we did here, again, was took this piece right here, right, and said, you know what, I'm going to take the integral of this plus the integral of this, and this negative sign is this one right here, right, from 1 to 4, and that's both pieces of this function, right? So we're going to take the area of one piece plus the area of the other one. However, it turns out that this one has a negative area, right? Well, depending on which way you look at it. So this was 9, and 9 minus 2.5 is that 6.5. So I hope that was helpful.